So welcome. I would like to introduce myself briefly, and then I will turn the microphone and tab the presentation over to Lisa Crow, my colleague, and we'll be presenting together actually. My name is Harlan Gilbert. I'm a math teacher in the high school. I also teach astronomy and philosophy, and my background has been really right through the breadth of Waldorf education. I began as an assistant in the nursery and an after-school teacher in the kindergarten, and that was my first introduction. I was asked to help out in a school by a friend who was working there, and the school needed somebody to come in. And I was very excited by what I saw. I stayed for a whole another year working as an assistant there, and then I went off to do a teacher training and became a class teacher for a number of years. I've taught grades 1 through 5, and in terms of math, also 8th grade. And then when I came to Green Meadow, I started working in the high school. And I've been here, this is my 11th year in the high school. And I've also been involved in the teacher training for adults for 11 years now at Sunbridge College, and also some other training programs for very occasional stints elsewhere. So from the earliest childhood right through to adulthood, I've been involved in Waldorf education at every level. And as an overview to the evening, I would like to mention that the special thing about Waldorf for me is that it takes the children's development seriously. For about 80 years now, we've known a great deal about child development, far more than we knew ever before. And that is largely through the initial stimulus of a psychologist named Jean Piaget, and then through a series of people who developed his work and extended it in many countries. And development is an interesting thing. Children go through stages, through different abilities, at a certain pace. We were just talking this evening about when my children developed their reading skills, and they remember very clearly the frustration of trying and trying and trying at a certain age and not being able to read, and then suddenly from one day to the next it was as if a veil had lifted and they were able to do it. And that was a door that if we had tried to push them through, they would have simply been compressed between our pressure and that crystal wall that they could sense something beyond but couldn't pass through. And Piaget remarked about this developmental pressure that he had lectured. He wrote this as a preface to the American edition of one of his books. He had lectured in about 40 countries by that time. And in every country, after his lecture, people would come to him and ask him, "This is wonderful. You have such an insight into child development. Now, how do we ground our schools in this? How do we make it so our schools are teaching developmentally so that children will really be able to benefit from your insight?" In every country, that is, except the United States. And when he came to the United States, people rushed up after the lecture to talk to him, and they said, "This is wonderful. You have such a picture of development. Now, how can we accelerate our children's development?" I think this idea that development is to be accelerated has spread now to many other countries, however. He wrote this back in the 50s, and the world is rapidly taking on this idea that faster is better. Hothouse flowers do not last the longest. So we are going to give you a little picture of what we see as the developmental path of Waldorf education, and how we try to work with what's naturally happening in the human being, in the developing human being, the child who's becoming something he or she is not yet, through the ages. We're going to take exemplary moments in that evolution. I'm going to pass this over to Lisa, and one of the things that is very characteristic about Waldorf education is that children don't just get talked to, lectured to, they're asked to do a lot. So we're going to ask you to come up and do a few things this evening as well, So we're going to go back and forth. Lisa's going to explain a few things, then I'm going to give some examples, and woven into those examples will be moments when I ask you to come up onto our workspace here and take on some of the interesting activities that the children have an opportunity to do.
Put these on to see how to pin this on. Yep. There we go. So I've written a few notes because I don't want to waste your time. I want to just bring you some nuggets tonight. And so I thought if I prepare something, then I'll stick to the plan. So that's why I've got paper, and Harlan's just speaking, so that's wonderful. I am very grateful to be with you this evening. I've been a class teacher. For 1 year I had a darling 3rd grade. And now I spend all my time with middle school and high school students and teaching mathematics to them. As you probably understand, I can spend a lot of time in class meetings explaining what we teach, so it's very exciting to come here tonight and talk about how we bring the curriculum. And so I was excited when Vicki brought us the topic to think about that. I did spend quite a bit of time thinking about what to bring, because it is a different question than we usually answer. And so I thought of the master teachers that I had seen in the classrooms, as well as my colleagues past and present. And I asked Harlan if he wouldn't mind if I spoke about or brought some pieces from the lower school, grades 1 through 8, because just being in their classrooms and being with them, they have such a way of bringing the curriculum so that it meets the children. And it's exciting to be in that atmosphere as an adult too. So what I thought I would do tonight is I'll bring 8 inspirations from these inspiring teachers that I've known and that I do know now. And as Harlan said, we'll bring examples. So either you'll be playing or he'll be talking about classes past, or I've got an example too to bring. So the first nugget. For the first years at school, everything that is seen and said must be beautiful. Whether it's the way the teacher speaks or the way he or she writes on the chalkboard, it must be such that the student sees the world is beautiful. When the students see such beauty, it inspires them to work carefully and beautifully in their books. And later, as this metamorphoses, it gives them the ability to have an active interest in the outside world. So what I want to do, just to show you some of the beauty that I get to see in the classrooms when I visit, and the students see every day, I'll have a slideshow running behind me of the main lesson chalkboard drawings of the teachers in the lower grades. And so we're just going to have this running as I speak. It goes chronologically, but maybe you can guess what the topics are as you go. When you came in, I had also had some of the children's work framed and sitting out there. I picked pieces that were beautiful. I thought really imbued beauty. But if you'd like to see the riggers, how they really work hard in their main lessons, you're welcome to look at their books as well. What I chose was beautiful, but there's also some very serious work that happens in those books. You can see those on the way out. One of Waldorf education's main goals is to educate the human being in thinking, feeling, and willing. Children are brought into contact with everything in the human and natural environments at just the right moment. During the class teacher years, in grades 1 through 8, none of this should be done in an abstract manner. Instead, it must be done so the children feel that these things have a direct relationship to them. And I think now Harlan is going to bring something from a first grade experience.
So this is an experience from, I'm going to embarrass her, my wife, who's sitting right here and was the first grade teacher last year. And the very first encounter of children with numbers is through counting, really. That's the simplest experience of mathematics. And counting is already a great abstraction. There are cultures in which you have the number one of something, you have a pair of hands, and then beyond that is many. If you want to count how many people are coming to dinner, you say there's Billy and Susie and John and Robert. That's how many people are coming to dinner. It's concrete. So what is this when we count? And in the first grade last year, they were introduced to counting by adding a bead onto a string for every day they had school. So the first day there was one bead and they could count to 1. Second day, 2 beads, they could count to 2, 3, 4, 1 for each day. And so this vivid concrete experience of the days of school piling on was represented in a very concrete way in front of them, and they naturally were able to count by the end of the year to 160 odd. And that meant something to them. That was a meaningful experience, that number. The beads were also differentiated into colors by month, and birthdays were a special bead color, and there were little special qualities that bloomed through that. Just as different numbers have special qualities, then the number 5 has a special quality. The numbers were not just completely all the same and abstract. They were a meaningful sequence of events that happened there.
As our life runs its course, it has rhythmical repetition that keeps us healthy. A good, healthy lesson also has a rhythm. Children must alternate in their lessons between movement and rest, between listening and being active, between being awake and immersing themselves in pictures. So my third gem would be, is that third? Yes, everything we do must be imbued with rhythm. And so now
we're all going to come up. In Hungary, they have a special kind of coach which is driven by 3 horses called troika. And we're going to see if we can form little teams. So together as a team. And now you start with another team in front of that. 4, 5. Okay, one more. 9. One more team. 10. You're in charge. You're right. Okay, very good. So you can turn, you can actually be a helper here. So I wonder how many horses we have here. Let's count. Can you each say a number? 1, 2, 3,
4, 5, 6, 7, 8,
9, 10,
11,
12,
13, 15.
Now we're going to do that again. And only the ones at the very end here will say their number loudly. The others will kind of whisper. 3,
6,
9, 12,
15.
That's it. And one more time, and this time we're going to count with them, but they're not even going to whisper. I'll just say it inside. 3,
6,
9, 12,
15.
So 1, 3 is 3 3s are. 4 3s are. 5 3s are. Now we're going to form a big circle. We'll see if we can practice that also. So, see if you could just do this. I'll follow you. Very good. And now we're going to turn in pairs. Face apart. Okay. And we're going to do the same thing, and you'll find when you do something magical is going to happen. So, and we're not even going to whisper. We're only going to say the one where we meet our partner. If I had been building that up in the class, it would work a little more and starting together. I didn't give it clear signal. And that would move then into the times tables proper. You can just try one last one. Can I step in here for a moment? Oh, sure. 1 is 3 is 6. Try it that way. Ready? 1 times 2 is 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. 5 times 3 is 15. 6 times 3 is 18. 7 times 3 is 21. 8 times 3 is 24. 9 times 3 is 7. 10 times 3 is 30. Backwards. 12 times 3 is 36. 11 times 3 is 33. 10 times 3 is 30. 9 times 3 is 27. 8 times 3 is 24. 7 times 3 is 21. 6 times 3 is 18. 5 times 3 is 15. 4 times 3 is 12. 3 times 3 is 9. 2 times 3 is 6. 1 times 3 is 3.
So Harlan, I've got 2 more inspirations I want to bring together with this next exercise. And I don't think I'm going to speak about them too much because I think your exercise or your description in the 4th grade will probably bring enough. So these 2 inspirations are you always teach from the whole to the parts. That's very important. And the art of teaching is sensing what the students need at any moment in time. So those are the 2. Let me give you that.
We introduce fractions going from a whole to a part in the 4th grade. And it's a very interesting moment in child development. It's the moment when children are beginning to distance themselves generally from their surroundings and not no longer to feel one enormous unity in which they are swimming. They're more conscious of roles, aspects of being good at something or not so good at something. A second grader who was the slowest in the class in my class once proudly told me that he was the fastest one in the whole group. So that's great. A third grader no longer, or towards say around 9.5, it often happens. The certain age, they're no longer so oblivious of their situation in regard to the whole. They're a fraction of the whole that they begin to see more clearly. And that can have serious social consequences. There are often cliques that form around this time. It's perhaps especially dangerous or difficult among the girls, but boys can have some problems too with that. In the earlier years, they may form groupings, but they tend to dissolve and blend and mix more, and they begin to get a little too fixed there. When you work with fractions, you take a portion of the whole, a half, third, a quarter, and then you begin to explore what can happen. Whenever you take a quarter, there's 3/4 left. So you become aware of what's left once you're removed, and you explore how 1/4 can be added back to 3/4, or 1/4 can be added to 1/2. And different fractions can combine in different ways. 1/4 is the same as 2/8, as 3/12. They change, they metamorphose. And so the dangers of becoming too fixed as either fixing yourself in your image of what you are as a fraction of the group, or fixing a clique, a fixed group, begin to be encouraged to be brought into movement by the fact that you're working with, talking about fractions, and then moving them and transforming them and allowing them to play with one another, one could say. That's a very important passage in children's life. That's not the only way it's addressed. There are also many mythological moments that address it in other aspects. But in mathematics, it's the natural moment to pick this up because children are coming to it as part of their own human development.
So we're on to number 6. It was always Rudolf Steiner's greatest wish that the Waldorf school should take its place purposefully and energetically in life as it really is. The children should not be taught anything that is not in touch with reality. Therefore, the teachers should do their best to relate everything to practical life. And I think now we're going to the 5th grade? 6th grade.
How many of you have ever had to make an interest payment? Sorry to hear it. Sit down. So, interest doesn't sound like a very interesting thing to learn about in many ways. But in 6th grade, the children are coming to interest in earthly things in a new way. Their bodies are becoming more earthly. They're becoming more interested in practical events around them. They're living a little less in a kind of big peripheral world. And there's a block of teaching, a subject that we introduce, business mathematics, which includes things like interest. And it's really a course in economy. And we begin with introducing the origins of economic systems. And the first economic system you find in simple cultures is barter. People traded for things. I had a big farm where I grew wheat. If you're a fisherman, I'm getting tired of eating only bread. Fish is wearing for you. What if we made a trade? And many classes will have a kind of flea market or barter stall where everyone can bring in things that they are willing to say goodbye to. Many of us have those things in our life, children as well. and they bring them in, and trades are possible. So you can come to someone else's little stand and say, well, I'll trade a bracelet for that nice ball there. And the person could say, I don't really want a bracelet, but, or yeah, okay, that sounds like a good trade to me. Or throw in one of those beans over there, the marbles. And so they begin to experience what it means to enter into an economic life where you have a surplus and someone else has a different surplus and you're willing to exchange. It becomes apparent that not all trades will be successful because of the problem that you may have something that no one wants. And one can easily imagine if a cow is what you'd like to sell, you've had a cow's given birth, and you'd like to pass on the new young one, which you don't need anymore, you're willing to trade that. You walk to market 10 miles with your cow, and nobody happens to want a cow that day, but they have all these things you'd like. There's meat and fish and wheat and vegetables, and you'd like a lot of it, but no one wants to trade for your cow. And you walk back week after week hoping to sell it. That can get tiresome after a while. Is there any way we can free up the economic life so maybe I could make a trade with somebody on a different basis? And this is the introduction of money. In early stages was often something like cowrie shells or something precious, gold in some countries, where I don't need to trade directly for wheat. Somebody might be interested in my cow. I can sell him my cow for money, and then I can go and buy the wheat. And there's a free exchange of goods possible. It's no longer locked into pairs of people who happen to want each other's things. And so money is a very sensible way to free up the economic life, to make it much more flexible. It's its real purpose. It's also much easier to carry to market than your cow. And from there, they can have an introduction to what happens when one person has a lot of, let's say, any commodity really, but could be, in this case, money. If you have a lot of money and someone wants to use that, well, do I just give it to you to use for a number of years? But then I can't do anything with it for all those years. I'm making a certain sacrifice. I'm not able to use it for those years. So perhaps I'm willing to allow you to make use of it if you'll give me some sort of consideration in return. Maybe you give me eggs every month, or maybe you give me money in interest as a reward for my offering that. So interest arises as you want to give me an interest in loaning you money. Why should I be interested in loaning you money? You want to make me interested in doing that. And that's the origin of interest. And then they learn about what markups are. So shops have to pay all sorts of background costs, their labor, lighting, so on. So they have a certain markup. They buy the goods for a certain cost. They mark that up and sell it for a higher cost. They also learn what it means to have a sale, 25% off. How do I figure out what the price is? $30 shirt, 25% off, what's that going to cost me? And then there's sales tax. You start getting to be faced with the complexities of modern life. And by the end of 6th grade, they should be able to handle questions like that. What does that mean if the shop bought something for $15, has a 75% markup, put it on 30% sale, but there's sales tax at the end of that process? Right? That's a practical question, which grows out of a real concern for meeting the needs of a real economic life, the practical needs of the real world.
Course material should not be defined in concepts, but it portrayed in vivid descriptions. A roaring river, the bright northern star, the discovery of algebra, and even ordinary life can be portrayed in meaningful pictures. Teachers must fill with inner conviction and warmth the pictures that they present to the children so that the children can derive strength for the whole of their adult life from lessons that stream from heart to heart rather than head to head. And for this, I have an example from my 7th grade class. I had the Algebra main lesson with them last year. And we did many things, reviewed the 6th grade and equations, some of the formulas they had then. But we needed to come to balancing of equations. And so I spent quite a bit of time like this with my hands in the air, talking about keeping things in balance and what you do to one side, you do to the other when we talked about equations. And so the earlier equations they could just solve in their heads. But then we started to have some questions where we couldn't just guess the answers, but there was a little more work involved. And so Mr. Davis loaned me his good old scale. And it really brought a picture to the students that they then drew in their main lesson books. And even this year I'm hearing from them that they were thinking about that as they were then solving more and more complex equations through the rest of 7th grade. So I don't know if I've turned this the right way for you to see it. Now it's far away. I didn't know where to set it exactly. But they were given a question at the end of one day. They were asked if I had 2 of some mysterious quantity and 9 more of these objects. And on the other side of my scale, I had 4 of this mysterious quantity and just 3 of these objects. What could the weight be of these objects? And of course they were to take that home at night and guess and see if they could figure out a way to do it. And when they came back the next day, we decided, we talked about what they'd thought of before they went to bed and when they woke up again, and there were a lot of wonderful ideas. But we thought that we would look at the 2 sides of the scale and try to simplify what was on the scale and then derive what the weight could be of these boxes. So the children came and helped, and we did this a few times because can we do it different ways? And it works, and of course it worked different ways. But we just started to take from one side and from the other in our simplification and bringing it back to balance each time. So we got rid of some of our boxes. We're down to 2 boxes now. And then we started to take individual weights just from each side while keeping our scale in balance. And we came to a point where we just had 2 of these boxes on one side and 6 of the weights. And of course, then they could do the work in their head that each of these magical boxes must weigh 3. So this was just something that we did. And then we did it in different ways, and I brought different boxes, and I called them Y, or I called them question mark, and we had cloth bags. So we did that a few times because we talked about how to make things simpler by doing algebra. And so this was a meaningful way for them. We're already at grade 8. And here we go. Adults quite rightly hesitate if they do not understand something. For children, it is usually the opposite. They need to do something and then understand it later. So my 8th gem that I want to bring tonight is understanding arises out of feeling and willing in these years. And now we need to move.
A little introduction, and we're going to go back.
Okay. Do you want this then?
I asked before how many of you have paid interest. Now my next question, how many of you have ever used the internet? This was, when I was a young man, this was a new idea. And it arose in good part out of a need by the Defense Department of the United States that was very worried that if all of communications went through a central exchange, and there were only a few central exchanges for the Defense Department's communications at that point, one good hit on that exchange would destroy all their possibility of communicating. And so they had someone there, and I don't know if anyone knows who it was that had the original idea, developed the idea of a distributed network. A network that would communicate in any direction, mutually, and so there were no key, not just 1 or 2 or 3 or even 10 or 20 key positions. that even if many different communication centers were destroyed, the net would be flexible enough simply to flow around that. And so we're going to have an experience of a distributed network. I'd like you to come up on the stage and just scatter yourself about. So who's feeling very quick today? Need someone who's feeling very lively and quick. Okay, Mr. Mesavage. You come over here. And who's feeling very receptive today? Somebody on the other end there. There we go. Okay. You're going to hold this. You're going to hold that up in the air, signifying that you are collecting all the green messages. And every message on the internet is labeled, and this green will serve as a label. This green label means it's heading over to that endpoint. We need to come a little closer together. Just a little bit. That's good. Okay. Now, Mr. Mesavage here would like to send a signal to that fellow over there. And on the internet, that might be that is a company, Amazon or somebody. And he wants to find out if the book he's looking for on mathematics is available. So he needs to communicate over to there. And what happens is that message gets divided up into small little packets. So each of these is one piece of the message, and all the packets have to arrive there, and he doesn't want to sit at his computer and wait a long time. So you're going to have to try to help him get those messages there very, very rapidly. We need one person maybe right near here. Okay. Come a little closer, maybe two. Okay. I think everybody could come a tiny bit closer. That would be helpful. Okay. So what's going to happen is, we're going to try this a few times and see if we can get better and better at it. Mr. Mesavage is going to try to send these to the end point there as rapidly as possible. And each one of you can look around. Maybe someone can come right here. Come in there. Each of you can look around and see who's nearby you. Those are the people you can easily get messages to. So you're going to try to hand, you're not going to throw the beans. You're going to hand them. And you're going to see how fast this whole pile can get down there.
Now, do I move around?
No. None of you will move. You just pass it by hand. So make sure you can reach. Some people maybe want to come a tiny bit closer even. Okay, ready? Go. You can't take them here. Only he can take them.
Quick. I want my book now. Sorry.
Is anybody timing us? I'm not good.
One at a time.
One on the floor.
Pack it on the floor. Drop data.
Unresponsive website here.
Okay, that's probably good. Okay, probably needed a basket down there. You did a very good job. You were very receptive. You're right. Okay, so now we're going to try the same thing on the other direction.
So that was called dialogue.
Okay. See if you get any better. So they're all going over to Jim Mesavage over down there at the other end. Ready? Go. One at a time. No. Only he can take them.
Oh, sorry.
His computer has to send them. No other computer can reach until he sends it out.
Oh, yeah. High speed.
Ah.
I got wireless. Sorry.
That's all right. Nope.
Okay. Poor Jim. Here you go. Okay. So, can you say a word about your strategies that you used there? What did you think about?
The second time was much more efficient.
Much more efficient? You're getting better? So what?
Became unemployed.
Uh-huh. Okay, there at the periphery, it wasn't efficient to send it around there? Right, no need?
Right.
Okay.
I got something because she was busy.
Okay, and that's exactly the system that your computers use. They hear who's free to receive this packet, and if the nearest straight line connection isn't available, they just turn to there. And that could be that they're down, the server's down for the day. Could be that they got nuked, which is what the Defense Department was thinking about. Or it could be just that they've got lots of packets that they're dealing with, and they don't have time to take in 6 more, and it's going to slow down the whole network if everyone tries to keep giving them to them. So the network just goes around them and finds someone who's free and passes it around. You did exactly what the network of servers on the internet does to get your message to another location. If you want to try something fancy, we'll have greens going across there and reds going across this way, which is what the internet's really like. Do you want to try that once?
Yeah.
Okay. So it'd be great to have a stand or something for these to go on. Yeah, chair would be great. So, is there a second chair there? James? Okay. So, do you want to be a sender? Okay. And who's the red receiver over on that end? Somebody across the way? Mesquite? Okay. So all the red ones are going to Mesquite, and all the green ones, let's choose 2 new people, actually. So who else would like to try to be a sender? Okay. You're a new sender, and who's a new receiver over there? Okay. So the greens are all going this way, and the reds are all going that way. Okay. You can put this wherever is most convenient, too. Green over there, red over there. Okay. You'll see in a moment because they'll be holding. Let's give you one so that people can see very vividly. There's a red, and there's a green. Greens are going there, and reds are going there. Okay. Ready? 1, 2, 3, go. You probably shouldn't receive greens. Yeah. Okay, you have to hand them. No, you can't throw them. You have to hand them. You could step in a little bit if you want to be more involved in the middle of the things there.
Am I receiving?
We got straight lines. Oh, I see. Here, green.
Yeah. Oh, there we go.
Go around.
Those guys in the middle are.
Get a system.
No variety.
Sorry, got it.
Okay, that's probably good. Okay, very good. So you have to imagine that in the real world, there are tens of thousands of messages going through each server at any one time. And so that you would hope that they're very clearly labeled so they can figure out which one, each one has its own color, has its own code that it's numbered with, so they can figure out. And the packets in real life are numbered too, so that when they get to the other end, are they arriving in any order? No. So they back at the other end, they have to be carefully numbered at that beginning end, so back at the other end, they can be put in the right sequence again, so that you can figure out what the heck the original message was.
Thank you. Just in conclusion, I wanted to give you just an image to take away with you, because we're ready to leave the grades now and go off to high school. So if you can just think of this or dream of this, that in the second 7-year period of their lives, from 7 to 14 years of age, the children are accompanied by all of their teachers through the gate of beauty out into the world. And off we go to high school.
How many of you have children that are in either the high school or the middle school? Oh, wow, quite a lot. Okay. So around the age of puberty, 12, 13 years, Piaget said, and Steiner also said, children enter a whole new phase of life where this rich feeling life is no longer really sufficient for them, and they're wanting to be addressed cognitively at that point. And you've all seen that, this awakening forces of judgment, which can be very critical, but also very acute. It's a whole new experience dealing with an adolescent. than dealing with these wonderful young children that are so fresh and joyful. And I have two myself, so 8th grader and a 10th grader. See, I speak from experience. And so the education from this age begins working with algebra, which is a highly abstract concept, and with principles of geometric proof. Can you prove Pythagorean theorem? And children are no longer interested in taking something on authority. In the earlier years, if you say the area of a square is the side squared, the area of a triangle, the area of a circle, you give them formulas, they'll find, oh, those formulas are true, this is why the weather works, this is what God is like. All those things they simply accept by and large. And then at a certain age, they don't want to accept that because someone said it. They want to penetrate it with their own thinking and understanding, and then they'll believe it. If they can think it for themselves, if they can see why it must be so with their thinking. And so the education is, in a way, as it's often been called, an education towards freedom, also in this sense that you are freer when you can penetrate the world with your own understanding. You become a free person in it when you have that capacity. So the mathematics turns to algebra, to proof and geometry. We work with number theory, which is the kind of question, if each of you sat in a different position in this hall, and every minute you shifted how you were sitting, how many different ways, how many minutes could you keep doing that before you would have to repeat something that you'd already, some configuration you'd already experienced? That'd be a hard thing just to try out, right? Yeah, I mean, when I leave, you can start trying that. But there are very clear ways of figuring that out. And that's interesting to students that you can penetrate that. You can actually figure out a real number for that. Or how many different ways are there of shuffling a deck of cards? How many different ways are there? And then what's your chance of shuffling it and getting them all in sequence? From ace of clubs, two of clubs, three of clubs, four of clubs, right through to jack of spades, queen of spades, king of spades, ace of spades. What's the chance of that happening? It turns out to be extraordinarily small. You could be shuffling once a second from now till the end of the universe, and you probably wouldn't actually ever have it happen. So don't bet on that happening. It's not a good bet. In 10th grade, they begin grasping a kind of overview of the world. You see this in their whole gesture of maturity in the 10th grade. When 10th graders come in, they usually are still very connected to a peer group. They're not so sure of who they are in life. By the end of the 10th grade or early in 11th grade, or somewhere in 11th grade, and somewhere in those years, child development is flexible. There's no one moment that it happens for everybody. They begin, I describe it as their heads coming up above the water. They kind of went under something when adolescence hit them with all the hormones and feelings and all that hit there. And they suddenly, their head rises above the water and they look around and they realize they are not their peer group. They are themselves, and whatever they do will have consequences for themselves. And if their peer group really wants to do something and they don't think it'd be a good idea, they often begin to have the maturity to say, you know what, I'm not interested. Or, maybe it's even a great thing to do for you guys, it's fine, but it's not for me. These clothes, you like them, that's cool. I like something else. And that overview we practice through doing surveying. They go out and survey the land, and through notating data, they can reconstruct a precise map of the land they've created. They often look at how maps of the whole globe are created, how you go from a spherical globe to a flat map. It's a very complex thing. You can't just peel it off, right? It'll get all funny and bumpy. There'll be gaps and holes. And they really enter the world of very strict logic. So they learn what it is to think completely logically, which is a kind of relief after the passion of the previous years. In 11th grade, they discover the limits of strict geometry and logic. We introduce a subject called projective geometry. Now, if I take my hands and run them along this surface here, I feel that my hands are not getting any closer together. And if I was to walk on a railroad track, and you were to walk on the other track, we would notice that we're not getting any closer together. Could hold hands, and we would be the same distance all the way along. But if you look at that railroad track, does it seem like it's staying the same distance apart as it goes off into the distance? Looks like it's getting closer together. This visual experience, our visual space, in our visual space, parallel lines get closer together as they go away from us, in our visual space. Whereas in our tactile space, in our touch space, they don't. So our touch sense tells us one thing about the world, and our sight tells us something else. And there's a whole geometry that was developed when perspective was discovered in the Renaissance, based on visual experience, where parallel lines meet, as they do when you draw in perspective. It's called perspective geometry, and it blows your mind because it contradicts all the things you've ever learned. Parallel lines never meet. Yeah, they do. Very clear. Just look. You can see that they do. And there's a very consistent geometry, which actually is a more general geometry than the Euclidean geometry that you learned in high school. It includes Euclidean geometry as a special set. If you pull that line where the points meet infinitely far away, then suddenly things go parallel. If you happen to pull that far enough away, then things are parallel. And in 12th grade, we culminate with calculus, with an exploration of infinity, the infinitely large, and the infinitely small. And those are worlds that are fascinating to comprehend just before you're ready to go off into the world of almost infinite possibilities. Have you ever counted how many colleges there are out there to choose from, how many careers there are to choose from? You're going out into a world of dramatic increase in possibility from what's happened only 2 years before. Those are a few key moments. There's much more in the curriculum than we would ever have time to present. But I think that's probably more than sufficient for this evening.